That's been around, that demo's been around for a long time, about 3 years now. And our CTO is, or our CEO rather, is just discovering it. And a few months ago, John and I got a call on a Saturday, and his admin said, Jonathan wants that balancing stick demo thing up in San Francisco on Monday. And we're like, we didn't even have one. This one was down at a customer site, and we had to pull the one out of our executive briefing center on the weekend and drag it up to San Francisco. Notice that, can I hold this up here? Okay, this is where we boot Solaris from. So Solaris and Java RTS is on this flash stick. And we boot from there and run on this embedded single board computer. This has some Java Lang threads to do some GUI work. If we could actually attach a GUI to this, we could look at some things going on and do some control there. And a periodic no-heap real-time thread with a 5 millisecond period control loop. So that's basically pretty simple system design, but it does show you we do non-real-time stuff and hard real-time stuff on the same VM. And we never get it mixed up. Now this is the next thing I wanted to talk about a little bit. It's the slot car programming contest. We did it last year at Java 1, and it was a really big success. So my marketing team has asked me to do it again, which I'm doing. But this year I wanted to do something slightly different, so I added traffic signals, 7 of them, to the track. Last year was a time trial, and everywhere you see the sensors here, or everywhere you see the numbers, there's a little sensor buried in the track, a little opto sensor, and it detects when the guide vane of the car goes past the sensor. And so the contestants got enough real-time Java code to get a 1 kilohertz process reading the variable that told them whether the car was over one of the 80 sensors. It didn't tell them which one, so they had to count the sensors. And it turns out that the 1 millisecond loop is precise enough to count the sensors and to never get it wrong. And they also had control over the voltage to the track. So they had to try to get the car around the track twice in the shortest amount of time. And we had about 200 people sign up, and about 20 people worked a lot on it. They didn't see much else at Java 1. And one guy was there as soon as the floor doors opened, he was there writing code, and he was the last one before we did the runoff. And he actually got in the runoff. This year, it's a little different. The traffic signals are around the track. There's 7 of them, and they turn green in sequence. They turn green for 200 milliseconds. And the idea is to drive the car through on the green. Each signal has a nominal time. If you get through on the nominal time, you get 200 points. If you get through at the nominal time plus 1 millisecond, you get 0 points. It's a hard deadline. And if you get through at 199 milliseconds prior, you get 1 point, and on up to the actual time. So it's going to be a point system. And it's really nice because the lights do a lot of flashing and things. There's one Java Lang thread for initialization, 2 real-time threads doing printouts, because you don't want to call print from an NHRT because it goes through the I/O subsystem, and that's not real-time, and it causes the NHRT to miss deadlines and miss sensors. So there's 2 real-time threads that are doing printing, and 2 periodic NHRTs, one for the infrastructure management code, my stuff, that kind of manages the contest and reads some other sensors, and the contestant control loop. And Dave can tell you we've got nice prizes this year as well. Now this is the really important one. This is what I'm excited about this year. This is a real industrial robot. It is the world's fastest industrial robot from ABB. And it's a new style. It's called a parallel robot. Notice that one of the things is there's no bending moments on these little rods here. There's only tension and compression. And so you can build a very light, very fast robot. It's somewhat inexpensively. This thing retails for about $45,000, which is cheap for an industrial quality robot. This end effector will accelerate with a 2-kilogram load at 10 Gs. It can do 150 pick and places in a minute with a 2-kilogram load. And there's some video. If we get, we'll show you later. I don't think we can actually get the video through the screen here, but there's a video of 8 of these in a row picking a croissant off a conveyor belt and putting them on another one. And it is scary, man. These things look really weird when they're working. So we're doing the whole control system for this on stock Java RTS 2.0, stock Solaris, stock Sun Ultra 40. And ABB is actually pretty interested. They gave us the kinematic equations for this thing because they're thinking, wow, you know, we've been building this big, huge controller. It's costing us a lot of money. And you guys say you can do it on this little set of boxes and software from Sun. Well, we'd like to see that. So they're actually pretty interested in this. Here's the architecture. There's 2 Java Lang threads for initialization and doing some file processing. 2 non-critical real-time threads for interaction with the kinematics and the GUI. 8 critical periodic real-time threads doing the kinematic and inverse kinematic equations on 12 millisecond periods. And 1 millisecond period NHRT for the low-level interface to the drive units. The on-floor demo of this, we're going to actually take pictures of people and go out and pull the edges out of the JPEG files, turn them into vectors and commands to the robot, and the robot's going to draw caricatures of people on the show floor. And then when we bring it up on stage, if that actually gets, if it gets on into a keynote, we're going to have it pick up a knife, and I'm going to put my hand on there, and it's going to move the knife between my fingers very quickly. Well, maybe not my hand. They don't want to let me do this. I don't know why. I'm just like, so we're going to use a surgical glove probably and fill it up with air or whatever. But you know, I'll put my hand there, Dave. Honest. I mean, I trust this thing. But it's, I mean, think about it. You know, 150 long. You know, I think it does a meter, almost a meter. It can go back and forth. 150 of those a second. Think about how fast it can go between your fingers. That's going to be exciting. And we have full NetBeans support, right? You can write all this code, all of those threads for that in NetBeans, in one VM, and they all work together happily. And I think I'm pretty much out of time. And we can do questions later. Thanks.